Jack Russell Terrier. Now, do you guys know how it works with dogs? Like, big dogs live less than small dogs.
It's like a turtle more than
I knew someone who used to buy a Great Dane every 8 years. That's how long they lasted. They were $2,000 a dog. They're not cheap. Lots of bulldogs are like really expensive too. $2,500, purebred bulldog. Okay, Great Dane. Yeah, 8 years. Do the math. Just to buy the dog, right? What's 2,000 divided by 8 years? $200-300 a year, approximately. Just to own the dog. Not to mention the 18 bags of food the thing eats a day, the shots, everything else. That's if it's healthy. Like expensive. Small dogs live longer. It's not uncommon for little dogs to live 20 years. That's it. Like Kylie here. Nibbles on Fruit Loops and Cheerios all day long. A couple of carrots. Go out in the garden, give her some leafage, and there you go. We're all good. Okay, it's a normal distribution. Normal problems. What does that mean? It means it makes a bell curve. That's what we did yesterday. With a, what's a symbol for mean? X bar, but here, because we're talking about a population, it is mu. Okay? So here it's mu, because this is a population of Jack Russell Terriers. Okay, the life expectancy of Jack is a normal distance with a mean of, on average, to use the word average, because mean is an average, but it's a special type of average, 14 years. I believe I looked this up, and that's the data I got. With a standard deviation, what's the symbol for standard deviation? Sigma. You don't have to memorize that. I'm not going to say what is this thing called in Greek, okay? But yeah, it's nice to know. Sigma of 1.5 years. So do we understand what this stuff says? You understand what your average mark is, because a couple times a year it's published and you actually look at it. Okay, that's a mean is what you knew as average, okay? Standard deviation is a measure of the dispersion of data about the mean. Okay? So it wouldn't make any sense if I said a dog lived on average 14 years and the standard deviation was 31 years. That wouldn't make any sense, would it? Because how could I have a dog living 31 years past 14, 45, and then another dog that never was born is like a negative? It doesn't make any sense, okay? This is a measure of the dispersion. If that's a really small number, then like if that's like very small, then that's what the graph looks like, okay? 14 and not many dogs live much further than that. If it's a pretty big number, then the dispersion kind of looks like that, right? So, A. What percentage of Jack Russell Terriers, but I'll just write dogs, live from 11 to 14? And B, what do you call a whole bunch of dogs? Oh, you cheater. In a pack of 670, how many will live longer than 18.5 years? probably not the one that's overfed with table scraps, like you see some of these people do. Like its stomach's dragging on the ground as it walks, right? Animal cruelty. Okay. Here's the key words. It's a normal distribution. What does that mean? What do we know from yesterday? Makes a bell curve, right? Which is symmetrical. That I told you. We know the mean is close to the median. I wrote that yesterday. I'm not going to write that again. Okay? And we know it makes a picture like this. Now, you don't have to copy this down because you kind of got it yesterday. And it's right here on your formula sheet. Okay? You will get this for your test. And by the way, I didn't put the percentages in there yesterday, but those are helpful. Okay? So I'll quickly do it. All right? We got this thing. It looks like this. Okay, nice little bell curve. Right here is the mean. And then this dashed line is the mean plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations. Okay, on the other side, we got mu minus 1 standard deviation, minus 2 standard deviations, and minus 3 standard deviations. Okay, 68% of the data is within 1 standard deviation. So what does that mean if this is symmetrical? 34% of the standard deviation is from the mean up to 1 standard deviation away, and 34% is between the mean minus 1 standard deviation. 95% is from there to there, within 2 standard deviations. So if I do the math, and I go 95% minus 68% divided by 2, I gotta look it up, I get 13.5%. Okay? You don't have to figure that out. There it is, right there for you. This is also 13.5%. 3 standard deviations is 99.7%. Okay? So again, if I take 99.7 and minus 95, then I get 4.7%. If I divide that in half, that's 2.35%. And then these last little bits over here, well, this is 100%. This is everything, okay? Whatever data we're talking about. So if all of that from here to here is 99.7, then this little bit and that little bit add up to 0.3%, 100 minus 99.7. So that little bit is 0.15, and that little bit is 0.15. I don't think that is on your graph, okay? These other guys are 34, 13.5, 2.35, but it doesn't say 0.15. So that either stick it in your noodle or just work it out the way I just did. Okay, for this particular question, what is mu? It's 14. So you put it right there. Let's use not red. Okay, so 1 standard deviation, this line is 14 plus 1.5. That's 15.5. This is what you want to do with each question. Quickly do this little graph. Tyson? I said don't copy this graph here because you have it, but this part, let me just do that again, okay? Yeah, let's do this. Copy this. For this question, okay? Pretend that's not there because you're going to look that on your sheet. So now I'm doing this question, okay? Normal distribution, blah, 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 okay? I want to do this. That's 14. One standard deviation above it is 14 plus 1.5. 15.5. One standard deviation below that is 14 minus one standard deviation. What's 14 minus a half? 12.5. Okay? Two standard deviations. 14 plus 2 1.5s, or I already got 15.5 here. So what's one more of them? What's 15.5 and 1.5? 17. And two standard deviations below is 14 minus 1.5 minus 1.5, which is 11. Okay? The last one, three standard deviations, 17 and 1.5 is 18.5. Oh, have we seen that number here somewhere? We're going to give you numbers that are going to be nice. Okay, they're going to work. 11 minus 3 standard deviations, 14 minus 3 standard deviations, 11 minus 1.5 is 9.5. Okay, that's it. That's this question. What dogs live from 11 to 14? That is from here to there. What percentage of dogs? Look on your chart. That's this column, and that's that column. It's 34% and 13.5%. 47.5% of dogs. Okay? Because it's a normal distribution. 34, 13.5, A, from 11 to 14 years. That equals 34 plus 13.5 is 47.5%. Almost half of all the dogs will live between 11 and 14. Does that seem reasonable? Makes sense, right? It doesn't ask it, but also the same amount of percent will live from 14 to 17. Because these two columns are exactly the same as those ones, right? Okay? So any question you get, you just look at this table that you just made in 10 seconds, you compare it with the page you got with the percents, and it's not that hard, all right? B, any questions? In a pack of 670, how many will live longer than 18.5? That is this. Where's my other highlighter? There we go. That tiny bit right there. Like, that's pretty uncommon. A dog will live 18.5 when the average life expectancy for that dog's 14. Okay? Had a good life. You kept him away from cars and everything. What percent is that? This and this is 0.3. So this little bit is 0.15%. Okay? That's 0.15% of all the dogs. I'm just giving you a number. So what's 0.15% of 670? Now, how do we times by percents again? Because that's out of 100, right? So to make a percent, like for instance, your mark is 70%, right? Divide by 100. 7/10, right? 0.7 as a decimal. Divide by 100. So divide that by 100. 0.15, yeah, it's going to be a little number. Move the decimal 2 spots to the left, times that by 670, and make sure your answer makes sense. 1.005 dogs. Can you have 0.005 dogs? Can I have half a dog? No. It's cruel, right? So like the front half or the back half. So obviously we're going to round this to the nearest dog. All right, 1 dog out of 670. Anybody else feeling hungry for lunch? Okay. When I say dog, I think hot dog. I don't think Jack Russell Terrier. Okay? I could ask you 12 different questions with this one little table, right? How many dogs live 12 and a half to 14, 15 and a half to 17, 9 and a half to 11, 9, okay? Just look at the numbers. It's not that hard. 253, 10, 214. And like I told some of you yesterday, it's okay to just peek in the back, see what they're saying for an answer. Sometimes these questions are a little confusing and go, oh, okay. The bottom line here is you want to learn from it, right? So it'll be on the test. Now hang on, number 14, just one little thing. They use the word generally. So if I say the dogs generally live, what are they saying? Does that mean 95%? 99.7%? It means 99.7. I only know that because I had to do the question and work backwards and figure out what they were trying to ask. Okay? So generally means 99.7%. That's just for number 14. Okay?